you know how many people are affected due to industrial pollution worldwide? Any idea? So just to give you an idea, there are thousands of people affected due to industrial pollution, which is created by industry. And I have seen some of the countries where spent acid or acids are being thrown in sea. So I think it's a very challenging time in order to protect the environment, and we have to do something because there are many people affected, and maybe our close ones may be affected because of that going forward. So I think as a responsible corporate citizens, we have to take some actions in order to resolve these environmental issues. So my name is Bhavesh Shah. I am, like he has mentioned, I am a chemical engineer with more than 24 years of industrial experience in a similar industry. And I'm going to present you today some of the key technological aspects of such acid treatment, which definitely will help you to increase your knowledge and will help you to have some kind of decision making in your investments going forward. So brief agenda which I'm going to cover in this presentation is nitric acid concentration technologies, because there are certain nitric and spent acids which are generated, which is mixed, and you need some kind of concentration and purification technology. So I will cover that. After that, sulfuric acid, which is the most commonly used in various specialty chemicals or pharma, where it is used as a in a reaction as a not catalyst but as a carrier, and you generate a lot of spent sulfuric acid with mixture of various other impurities or nitric acid. So recovery of that technologies are also they are operating in many parts of the world. So that I will cover, and then I will cover some of our inorganic technology solutions which can definitely, and what is our background and what we do. And the last one is a summary and what is the takeaways from this presentation. So for nitric acid, mainly if you see in terms of nitric acid, there are fresh nitric acid which is produced from ammonia, and generally with ammonia oxidation you produce around 60 to 65% of nitric acid, because that is a azeotrope point. Beyond that you cannot go that concentration. So for that, if you want to produce up to 98%, which is called a concentrated nitric acid, there is a technology in order to concentrate that acid up to 98.5 or 99%. So in this process, there are basically after azeotrope you need some extractive agent in order to concentrate that acid. So this is a brief flow diagram how it works. So pre-concentration, then there is a extraction by, there are two extractive agents which we use, and widely popular one is a magnesium nitrate and another one is a sulfuric acid. So that extractive agent is used to concentrate the nitric acid, and then you get a nitric acid which needs some bleaching, and you get a pure nitric acid. In this process, there are certain NOx which has formed because of this is operated at a high temperature. So there is an inbuilt process of NOx absorption system which caters to a pollution norms of emission, because in certain countries there are strict norms for NOx emission. So that is taken care, and that NOx is again converted into nitric acid and recycled back to the process. So there is no loss of nitric acid in this process. So very efficient NOx absorption system is also part of that overall process. So NAPC is a pre-concentration. Certain old plants of nitric acid where they produce 50 or 60% of nitric acid, where in some of the processes you need 65, 70 or some kind of medium concentration of nitric acid. So that technology is a NAPC, we call nitric acid pre-concentration. That is also possible, and rest I already discussed, like magnesium nitrate and sulfuric acid based. This is NOx absorption system. So now comparing these two technologies, majority of customer asks why Magnac or why Naxac. So here magnesium nitrate solution is used as an extractive agent, and here it is nitric acid, sulfuric acid is used as an extractive agent. So in magnesium nitrate, it is applicable only for a fresh nitric acid. So whenever you have WNA, weak nitric acid, from a ammonia oxidation process and you want to concentrate, then magnesium nitrate is the only process you can use sulfuric acid one also, but magnesium nitrate is applicable only to the fresh nitric acid. An advantage of this process is it has a lower capex, because as you know, we are handling very high and concentrated and strong acids. The investments in terms of equipment require some exotic material. But for magnesium nitrate part, we can use some of the stainless steel equipment which can lower the overall capex of the project. And another important advantage of this technology is this process condensate, which is you get as a water after concentration, you can recycle back in a weak nitric acid plant. So this is another advantage, because here it's a reusable. In sulfuric acid reconcentration process, we use sulfuric acid as a extractive agent. This basically advantage of this technology is it can be used with the spent and fresh acid. So if suppose someone has some spent nitric acid coming out of some of the processes, it can be used this sulfuric acid based concentration technologies. And here also, if there are any organic impurities are there in that process of feed of spent acid, we can oxidize it and we can purify that acid and recycle back to the process. So I think that covers brief about nitric acid concentration technologies. Now I'm focusing now on sulfuric acid as a spent acid, which is generated in various chemical processes like industries. If you see, there are these industries where sulfuric acid is used as a process carrier, and they generate various spent acids. So starting from titanium dioxide, copper refinery, then there are explosives, again lithium extractions, there are pharma and various specialty chemicals, pharma intermediates, where sulfuric acid is widely used as a carrier in the reaction in order to absorb the water which is generated in the process. So that water gets added in the acid and you generate a dilute spent acid. So challenges, see, for this spent acid, there are many challenges industries facing. So mainly environment norms are getting stricter day by day in terms of their disposal, their reuse, and where it can be used, because it contains some of the organic impurities where governments do not allow to use that kind of acids in a further processing. So that is a very challenging problems these producers are facing. Then another aspects, mainly, some of the producers are neutralizing this acid with some kind of alkali and producing some kind of byproduct, but it has a huge cost. As you know, neutralization, if they use whatever kind of neutralizing agent, the cost associated with that is very high, and the value generated by that byproduct is very low. So it's basically a high cost option, and definitely there are various other challenges, but these are the main, and currently the main challenge is the environment and the cost associated with the treatment of this spent acid. So I will focus on this what are the technologies available to treat this spent acid coming from various industries. So we have technology to cover starting from 10%, 15% sulfuric acid which is generated from any process. So there is a medium concentration or low concentration. We can concentrate up to 60, 65, 70 depending on your process requirement, and you can then we purify it, remove the impurities, and you can recycle back into your process. So your fresh acid consumption gets reduced. And materials used of various equipment, because it's a very highly corrosive application in the process. So we use graphite, PFA, PTFE line, Hastelloy, and that kind of material of construction we are talking about in a low concentration range. Now, even someone wants this concentration to be as high as 98% pure sulfuric acid. We also have experience and we have supplied many plants, and that is also possible. But here, the main challenge or maybe requirement of process is some of the most exotic materials are needed, like tantalum, silicon carbide. So capex point of view, I generally suggest to the customer that they have to balance what concentration you need. Up to 92%, it is still there are silicon carbide or that kind of material is not required, but tantalum is definitely required, and we can optimize, and there are solutions in order to concentrate up to from 93 to 98%. And definitely these are very well proven technologies and operating the plant since more than 20-25 years. So this is the photograph of acid. You can see spent acid, which was basically coming from one of the process, which is a dark color, and at the end you see the crystal clear sulfuric acid, which is concentrated up to 98% after removing all the other impurities, because color is basically from the organic or other inorganic impurities which is coming from the acid. So we have a capability to completely remove that impurities from the process and use this acid as a fresh acid. Of course, it depends on the application, what kind of impurity allowed in your process. So we can work closely and customize a particular plant for a required capacity or quality. So here, modular process design approach we have. So removal of contaminants. There are kind of stripping is associated if there are two acids, or if it is a single acid, it is not needed. Then thermochemical oxidation, it is inbuilt in that process, where if you have some kind of organic impurities, we have that kind of thermal chemical oxidation by which you can remove and decompose those organic impurities. And then precipitation, filtration, depending on inorganic salt content in the acid, that can be combined. Then separation of acid mixtures. If there are two acids, for example, nitric and sulfuric acid, there is a rectification process available. And finally, acid concentration and absorption. So acid concentration is a removal of water, which depends on atmospheric vacuum or pressure. Depending on your steam availability, we can design that plant based on your utility requirement. And last is absorption. It is for NOx. So like I said earlier, this is again another sample of various concentrated levels. If you see, first is a very dilute with a lot of impurities, and then there is a medium concentration, and you can see how the color is changing with the various concentration levels. And if you remove the more impurities, your color of the acid will become like a pure acid. So this is a modular process designed for DENSAC. So this is our proprietary name of denitration and sulfuric acid, where you have 10-20% of nitric acid and maybe 20-30% of sulfuric acid. So we remove that nitric acid and separate and concentrate up to some weak nitric acid level, like 50 to 55% in that range. And in the second part, you get the purified concentrated sulfuric acid of whatever concentration you need there. And this is one case study of titanium dioxide production, where sulfuric acid is a major use in terms of their process. So there, basically, it's not only about concentration of sulfuric acid, but also there are certain inorganic salts like ferrous sulfates and all other inorganic salts which has to be removed before sulfuric acid is being concentrated. So it's a combined process of evaporation and crystallization, where we remove all the inorganic salts from the process, and then sulfuric acid is purified in a next stage. Again, there are various options, like I mentioned earlier, atmospheric, vacuum, and this process can be customized and designed based on specific application of the process. So the idea is to show there are various combinations that we have done in order to achieve either 60 or 80 or even 98%. So this was mainly about some of the technologies in terms of purification of acids, which definitely are working, and we have many commercial references in India. Also, we are working with some of the customers in order to provide this solution. And again, I will just briefly cover what is KBR and what is Ecoplanning and Plinke. So Ecoplanning and Plinke is a company 100% owned by KBR. KBR is a US company, and both has more than many operating references in a respective field. So Ecoplanning, if you see, they are expert in evaporation and crystallization of inorganic salts, where and also acid concentration of low range, like up to 60%. And we have also some inorganics technologies for zero liquid discharge, treatment of and purification of minerals like lithium, battery chemicals, nickel sulfate, cobalt sulfate, all kind of inorganic crystallization evaporation technology. Ecoplanning is taken care. Plinke is a world leader in acid concentration, and we have many many references for this acid treatment, and there are many processes and equipments which are patented by Plinke. And mainly the expertise, the material selection required for that particular application, which is key. Some of the applications you do not need always a high-end exotic material. So that expertise of selecting right material required for that particular concentration is a expertise that we can bring. So overall, we have 750 technology references all over the world, catering to both the technologies, 150 plus of years of experience, 40 technical experts. All these technologies, mainly all technology experts are in Germany, based near Frankfurt. And we have 20 plus registered patents covering all the parts wherever there are certain pieces where you need a patent for certain applications. So we have total 20 patents, and we have most important is a laboratory where, generally what we suggest that you send your spent acid, we test it, because there are certain components which are explosive. Even if they are organic, there are certain processes we have to check, and we provide that services in order to, before you provide us any commercial plant, we test it and design based on the specific requirement of that acid. So I think I have covered all the technology portfolio, mainly whatever we are catering, like concentrated nitric acid, sodium chlorate, sulfuric acid is already there, but there are certain processes which we offer as a complete group, as an inorganics technology portfolio, which covers nitrobenzene, which is another important product which is used in pharma and intermediates, which is adiabatic nitration of benzene and chlorobenzene. Purified phosphoric acid, which is used for food grade applications. Lithium, which is used in electric vehicle. So that technologies we have, and I think these all industries which we cover all over the globe. So while most important design criteria or engineering criteria we have is the energy. Whatever processes we design, energy is a key focus, because sustainability is a key driver for not only for KBR but all over the globe. So energy consumption or energy saving, integration of the process in various modules. For example, whatever process flow diagram I shown, there are many integration within 2 units in order to optimize the energy requirement of the process. So environment protection and emission. So emission catering to the required laws of particular country or region, we know all this, and we work according to the requirement of that emission norm. So these are the most important criteria we have in our design, including effluent water, safety of personal and environment, and reliability and availability. So these plants are at times so critical in terms of application. So reliability of these plants are very important in terms of design and operation. So these are some examples of material of constructions we have handled. It's not only about the equipment, but the design and selection. Fabrication is the next part, but before that, it comes like selection of appropriate material of construction for the particular application. That's what is our expertise in terms of stainless steel, silicon carbide, niobium, graphite. These are all applications used in this sector, including tantalum, titanium, zirconium, niobium. So this already we have handled, and we have experience working with these materials. And another most important material of construction used in this process is a glass lined. And this glass lined is not a typical glass lined which is basically used in various chemical companies, like it's a reactor or kind of vessel, but it's operating at a very high temperature. So it requires some special kind of glass lining in order to improve the life of that equipment. Yeah. So these are some of the photos of our installations you can see. And scope, it's generally a normal like technology, basic engineering, detail engineering, supply of proprietary equipment and support at site. This is the basic scope we cater in our technologies. And laboratory, like I already discussed, that we have a laboratory in Bathambur where all the tests can be done, and it can help you to get confidence in whatever solutions we are providing to you. We can show the results of that labs, and definitely it will help you to understand the process well. We have one pilot plant also where some medium size tests are required, that can also be done. So in summary, like I said earlier, these are the various key values in terms of our technologies which we offer. It's a single stop solution for any concentration range we provide in the sulfuric acid or spent acid or nitric acid treatment. Some of the companies may provide certain part, but here as a KBR we can provide a complete solution from any concentration range. Low energy consumption, we have various technologies in like MVR, mechanical vapor recompression, thermal vapor recompressions, or multiple stage evaporator, which can definitely help to optimize the overall energy input of the processes. CapEx point of view also, we work with the various sustainable business partners globally in order to keep that CapEx, because some of the equipments are so expensive in terms of material of construction. So we work with the various global reputed vendors in order to optimize our CapEx in order to make your project viable. And there is a continuous development in this technology over a period of time with various experience we are getting from our new plants. So I think this is overall I wanted to present. So from our technologies, you get a sustainable technology which can work for years and years without having too much of problem in terms of maintenance or reliability. Safety is our most important criteria while designing the plant, not only for us, for our customer working on site or for their personal safety is a topmost priority. And most importantly, at the end of the day, customer will say, what is in for me? So we try to create a solution or offer a solution which is profitable. After having that unit, at the end of the day, you should also get some kind of benefit, either environmental point of view or profit from the product or byproduct which you are generating from the process. So I think that's all about my presentation. Any question, comments are welcome. Thank you for your patience listening.
Thank you, Mr. Shah.
Good morning.
Good morning.
Good
afternoon. Yeah,
okay.
Go ahead.
I'm Didi Vaishnav from GNFC TDI Dahej.
Which one is it?
GNFC TDI Dahej unit.
DNFs. Oh, okay.
Yeah,
Our reputed customer.
Yeah.
Please go ahead.
So in fact, we would like to sit with you if possible after this session is over, because
Sure.
there are so many, you must be knowing, email correspondences.
Yeah.
Last year we had one
Correct.
web-based meeting also.
Correct.
We were there with
Right.
our then GM Mr. Nitin Patel.
Right.
So no need to deliberate much here, but we want to, basically there are issues which need to be resolved.
Sure. Definitely.
So
Definitely.
basically,
And I
we are
think-
very much concerned,
Right.
because our plant commissioned in 2013, it is
Right.
operating, but
Right.
then there are certain issues
Mm-hmm.
which we would like to resolve.
Sure. Definitely.
So, sir, I need your appointment. We would
Sure.
like to sit with you.
Definitely. And see, whatever issues you may be having, maybe from operation point of view or maintenance point of view, I think we'll definitely there and going to support you for whatever you need. So we will discuss in detail and we'll try to find a solution. That's
Thank you,
our commitment.
Thank you, sir.
Thank you.
Generating some waste solids like metal oxides and other things. How do you plan to utilize that? Because till today, in cement bypass system, the chlorine powder is of no use to the system. So how do you intend to use metal oxide powders?
See, our job is to separate. It is present in the acid. So you cannot do it with anything. That acid is either you have to dispose by selling to someone or by having some kind of different neutralization processes. But here, what we are saying, that purifying that acid as a byproduct, and whatever little component is balanced like a salt, you get as a solid, and handling that solid waste is not that critical compared to 100% of, for example, if you have 100 kg of acid, you will get 1 kg or less than that as a product of that salt. So that generally we have seen that some of the customers, what they do, they dispose it as a landfilling if it is allowed and used, or maybe they further purify if there is a value from that metal oxide like ferrous sulfate, so that can be used in a further downstream processing if there is any value. So our expertise is to give you that to resolve your problem from liquid and provide you that two different products, and then after use is depend on what kind of product it is, byproduct generated from that process, and you can definitely find a use. But your problem is greatly reduced because your main problem is acid, and definitely we can find some of our international customers, if that is a similar application you are talking, then we can see what they do, and generally there are ways to tackle to the solid waste. It's not difficult like a spent acid. Hello.
Good afternoon to you.
Good afternoon.
I missed your presentation. I came just now. Now, regarding lithium, I want to just to know what is the future outlook you are foreseeing for lithium. Since we are the active, consumer of lithium. So I want to know about that, sir. If you can.
So
just guide
yeah,
me
it's
about
a
that.
great question. Your consumer as a application point of view, grease is okay. So your consumption may be very low in a total supply chain, maybe compared to the electric vehicles which are going to. So you are going to suffer. That's what I would say, because there is a huge demand in a lithium, because there are many companies, all over automobile companies. They have already announced that they are going to use only an electric vehicle after certain years, and because of that, there are many projects coming up where there are lithium mines, mainly Australia, Latin America, for example, Argentina, Chile, and some of the North American like US and Canada, and Russia to some extent. So there is a huge the production is planned, but still that sector is in an initial stage. So there is many developments going on to extract that lithium from mine, because whatever application till now we had, it was like 2 to 3% of global requirement in terms of electric vehicles. So because electric vehicles, it is going to be a huge market. So to answer your question, yes, you have seen the trend in prices like in last 2 years, from $20,000 a ton to almost $70,000 per ton. So that itself shows that lithium is a next boom. And definitely in India, unfortunately, we do not have that resource as a material. But I think for India, from that perspective, recycling of all these batteries, we also have that process of recycling of that lithium batteries, from where you have to extract lithium compounds and some of the nickel sulfate, cobalt sulfate, and that will be the key going forward for India. And I hope it answers your question. Yeah.
Thank you, gentlemen, and thank you for the questions. We would like to thank Mr. Shah for
Thank
that
you.
excellent
Thank you.
presentation. Thank you.
Thank you very much. Thank you.
There seems to be one more question. So,
Yes, sir. Good afternoon.
Good afternoon.
Sir, I just wanted to know if you want to go for a sulfuric acid recovery plant, what will be the minimum plant capacity and what will be the capex?
We can work with, like I said, we have supplied some of the pilot plants or semi-commercial plant as well, because the application of this technology is very, very specific. So it's not like you keep producing tons of material from this plant. So we are very open in terms of minimum plant, even if it is 100 kg per hour or 500 kg per hour. So we work for that kind of customized technology solution. That is one. The another thing is, if your plant is smaller, your capex will be slightly higher. That is the economies of scale. And mainly, if you see the engineering involved in a 10 times bigger plant or a small plant, engineering cost associated with that is same. In terms of absolute number. So lower the plant, the capex would be higher. But we are open and we provide all kind of capacities. There is no restriction. And roughly, to give you idea of capex, we are talking about around 1 to 1.5 million if you see the lowest size capacity of the plant, in that range. And again, that depends on what is the price of sulfuric acid, and we can help you to optimize that, and at the end make that project viable. Because if you see now, the sulfuric acid prices are like 10, 15 or 20 in that range, and definitely it is going to get viable, and we can assure you will have a payback period of less than 3 years with the current sulfuric acid price. And when it was like 2 rupees or 5 rupees, at that time it was not possible, but currently definitely it will. And again, someone has to see this historic price variation. I have seen a customer, like today, if it is a 15, 20 rupees, they will come. No, we want it very fast. Please provide it. And again, tomorrow, if it is a 4 rupees or 5 rupees, they are again slow down. So someone has to see an average historical price and take that decision in order to make the fluctuations also cater. And another thing is your dependency of that spend acid on outsiders. That is creating a problem of your main product loss. because that main product is affected when there is no disposal for same acid. So I think in holistic view, if someone takes, then definitely that project is viable. Yeah. Thank you.